Question 11, Part F, Part 1. Use the binomial theorem to find an expression for the constant term in the expansion of 2x cubed minus 1 over x in brackets to the power of 12. Let tk be any particular term in this binomial expansion where k is an integer between 0 and n inclusive. So we get tk is equal to n choose k times 2x cubed in brackets to the power of n minus k times negative x to the power of negative 1 in brackets to the power of k. And that equals negative 1 in brackets to the power of k times n choose k times 2 to the power of n minus k times x to the power of 3n minus 3k times x to the power of negative k. Now, if you're wondering where this negative 1 to the power of k comes from, that comes from this particular negative here. Negative x to the power of negative 1 can be expressed as negative 1 times x to the power of negative 1. And that's where this negative 1 in brackets to the power of k comes from. Also, if we expand this bracket here, that's where we get the 2 to the power of n minus k times x to the power of 3n minus 3k, applying the power of a power index law. Now we're multiplying two terms here with the same base, that is a base of x. So we add these two indices together. So we get tk is equal to negative 1 in brackets to the power of k times n choose k times 2 to the power of n minus k times x to the power of 3n minus 4k. Now to find the constant term, we want the value of the index of x to equal 0. So we want to find a value of k such that 3n minus 4k is equal to 0 when n is equal to 12. So substituting n equals 12 into this equation here and solving for k, we get 3 times 12 minus 4k is equal to 0. So 36 minus 4k equals 0. Therefore, k is equal to 9. So going back to this equation here, so using the binomial theorem, we want the value of t9. So the constant term is given by negative 1 in brackets to the power of 9 times 12 choose 9 times 2 to the power of 3. And that equals negative 1,760. Part 2. For what values of n does 2x cubed minus 1 over x in brackets to the power of n have a non-zero constant term? For the binomial expansion to have a non-zero constant term, we want 3n minus 4k to equal 0. Now this comes from part 1, where k and n are integers. Rearranging this equation, we get 3n is equal to 4k. Now the question is asking for values of n, such that the binomial expansion has a non-zero constant term. So we know that k is an integer, so 4k is a multiple of 4, which means that 3n must also be a multiple of 4. And if 3n is a multiple of 4, then n itself must also be a multiple of 4 for a non-zero constant term in the binomial expansion.